Now let's talk about the Ethereum virtual machine, because this is one of the most important inventions for blockchains, not only for Ethereum, but lots of other blockchains who have used this model to create their own chains. So we're going to talk about what the Ethereum virtual machine is in this video, how it works, and why it's so important. So let's first define, what is a virtual machine before we talk about the Ethereum virtual machine and why it's so important. So a virtual machine is a compute resource that uses software instead of physical computers to run programs and deploy applications. So one really common use case for regular virtual machines is running an operating system on top of another operating system that you don't currently operate. So I know that sounds kind of confusing, but let me use an example here. So you might see an example where somebody has a Macintosh computer, or an Apple computer, and they don't have Windows installed on it, of course, because it's a Mac, and they want to run Windows. So they might install something called a VM, or a virtual machine, essentially on their computer that essentially is software that acts like a regular computer, so they can install Windows and then run it inside of their own Macintosh, installation, or Mac OS installation, and vice versa. Somebody might have a Windows computer and they might want to run Linux inside of their computer. So they, instead of just creating a Linux computer from scratch, they might install a virtual machine or a VM, inside of their Windows installation to run a different operating system to act like a computer inside of a computer. And so the big, important function of this virtual machine really is just to be able to run programs in a virtual environment. That's the whole point, is you can create some software that sort of acts like a computer, all right? And so in this case, for a personal computer, the virtual machine just exists on one computer, and it lets you run programs in that environment. Now let's look at the Ethereum virtual machine and how it's different and quite unique. So the Ethereum virtual machine, or the EVM, is a virtual machine that essentially lets people run blockchain programs across the entire blockchain. So that looks like this. So, let's just say this is an example of the Ethereum network with just 4 nodes, okay? So each of these nodes is a computer, all right? It might be a server, it might be a personal computer, it doesn't really matter. But each of these nodes installs something called the client software, okay? And the client software is basically what lets you run the Ethereum virtual machine. But here's where it's different. You don't just run the Ethereum virtual machine on an individual computer. All these computers work together to contribute their resources to one network-wide Ethereum virtual machine. So the Ethereum virtual machine is sort of like a meta computer that is powered by all these different computers, all these decentralized nodes running different client software that implement the Ethereum virtual machine. So it doesn't just exist on one computer. It does, but in order for it to actually work properly, it has to exist on all these different computers to use their computational resources together to validate transactions so that they can execute programs with smart contracts on the blockchain. So one of the reasons that the Ethereum virtual machine is so important is that it lets blockchains run programs. All right, that's one of the reasons it was an insanely important invention, is because prior to the Ethereum virtual machine, we didn't really have a good way to run sophisticated programs with blockchains. And ever since the Ethereum virtual machine was implemented, we've seen lots of other derivations of the Ethereum virtual machine copied to other blockchains because it's such a profound implementation, okay? So let's talk about how that works. And this is the main thing that I want to focus on. There's lots of stuff you can do with the Ethereum virtual machine. You can go super, super duper deep, but I just want to give you the fundamental understanding that you need in order to effectively develop blockchain applications. So the primary thing is how you can write programs with smart contracts, because the Ethereum virtual machine is what lets you interpret those smart contracts, and it lets you execute the code that developers write so that other people can interact with them. So let's start off with the smart contract source code itself. All right, so here is an example of a really, really simple smart contract. Okay, this is written in Solidity. We're going to get into smart contracts a lot more in this bootcamp, don't worry. But in case you're just brand new and you're not familiar with this, this is Solidity source code for the smart contract. So what does source code mean? Well, source code basically just means human readable code. It means the type of code that developers can understand and they can write. So this is a programming language that developers use, is Solidity. You can write functions inside of here. You can create, variables, any complex logic you want to, all right? But that's not what the Ethereum virtual machine interprets and runs, okay? So anytime you're creating a smart contract, you have to take this human readable code and compile it down into byte code, okay? And so if you scroll down here on Etherscan, you can see the example of the byte code. So you take that source code, after you compile it, it turns into this. And this is what the computer itself understands. So when you put the smart contract on the blockchain, you actually send in this byte code, okay? And this byte code is what's able to further be interpreted by the Ethereum virtual machine. So let's look at how that works. So essentially, when you're putting smart contracts on the network, it goes through this life cycle of, essentially writing the Solidity source code, compiling it, all right, getting this byte code and deploying it to the network, and this gets, stored as bits and bytes and interpreted, all right, with the Ethereum virtual machine. And then anytime someone reads information from the blockchain, it does the reverse. Basically, you have these bits and bytes that get, read through the Ethereum virtual machine so that a human can understand the ending interaction that they're going to, do with the smart contracts themselves. So the EVM is sitting in the middle this entire time and is what's translating the important things between the end user and the actual instructions that get, executed on the chain. So now let's talk about that, because anytime that you are doing something on a blockchain, you are giving it instructions. So for example, let's say that I'm going to, take a cryptocurrency out of my account and put it in your account. That's really a transaction with really one instruction. You could think about it as two instructions: take cryptocurrency out of my account, put it in your account. I'm just going to call it one, instruction because it's a single action. Okay. And that's really ultimately what the Ethereum virtual machine is responsible for, taking these instructions and executing them. Because essentially, whenever you're doing an action on the blockchain, the entire public ledger is the state of the entire blockchain. Every single transaction is going to determine the current state. So if you've ever sent cryptocurrency around multiple times in your wallet, the EVM can interpret the state of the entire chain to see what your current balance is. And so really, anytime you trigger a transaction, it's like a state machine. It moves the blockchain from one state to another, okay? And so if you have a simple transaction where it takes cryptocurrency out of one account to another, it's responsible for, changing this state, or the state of your account and your balance. And more importantly, it actually executes things as a stack machine, right? That's the more proper way of describing it. So at the very lowest level of all this, you have these things called, instructions. Okay. So, anytime you say, hey, take funds out of my account and move it to another account, or let's say you're executing a smart contract function that has a lot of complex steps, all those instructions eventually get turned into these things called opcodes. Okay. And this is something that you don't really have to understand the depth of to become an effective blockchain developer. If you get really advanced, then you might want to dig into these for sure, so you can keep this reference handy for later. But essentially, this is what the machine actually understands, okay? You can see all these different opcodes that are linked together to perform the actions that you intend to do on the blockchain. And so, again, I'm not going to get super deep into all this. I don't want to overwhelm you, but you can see that here's all the different, codes here based on what you want to do: contract creation, contract interaction, call data, and you can see a table of the mnemonic that corresponds to each opcode, the stack input, the stack output, the expression, and then any notes that you want to follow there. So I'll leave this as a link for just a reference for further looking into if you want to really dig into this. But just know that at the very lowest level, that's what's happening here. All right. So another thing I want to talk about in regards to the Ethereum virtual machine are the clients themselves. Okay. So again, each blockchain node is a computer that is responsible for running the Ethereum virtual machine in tandem with other nodes. That's how they work. They all work together. All right. And each of these nodes has the virtual machine software installed on it. That's called the client. Okay. So there are multiple clients that we'll look at here in a minute that are implemented in a variety of different programming languages. Okay. And the language doesn't really matter as long as it conforms to the spec. Okay, so that's the other thing I want to introduce you to is the EVM specification or spec that basically just says, hey, whenever you do these certain things, like we saw the opcodes in a minute ago, that this is what should happen underneath the hood. They're all just responsible at the end of the day for making sure that those low-level instructions, like we just saw, take place. So that's the EVM spec, or the Ethereum virtual machine spec. And as long as you write an EVM client that implements that spec properly, it doesn't really matter what language you use as long as it can accomplish that. So let's look at some examples. So you can see some different examples of popular Ethereum clients here. So Geth is by far the most popular one. That's the Go implementation of Ethereum. That's what Geth stands for. You can see the language it's implemented in Go. All right, works on Linux, Windows, Mac OS. All right, Nethermind is another popular example. Again, it's implemented in a different programming language. Doesn't really matter what it is as long as it implements the spec. Okay, you've got Besu, which is a Java implementation. All right, works on these different operating systems, and so on and so forth. So these are the most popular Ethereum clients. Again, they are responsible for implementing this client software that conforms to the EVM specs so they can participate in maintaining the network. And so the final thing I'll leave you with in regards to the Ethereum virtual machine is, if you really want to get deep into how the Ethereum virtual machine works, okay, then I highly recommend checking out the Ethereum yellow paper. So in a previous section, we talked about the Ethereum white paper. The white paper is really just the idea that sort of pitches high level what Ethereum is, how it works, and why it's so important. And the yellow paper is the technical specification for how Ethereum works. It's way more advanced, okay? And so if you want to see, where some of the original ideas come from, like, Way and Ether and all these different denominations, that's in the yellow paper. If you want to see more about the opcodes and the math and the instruction behind the Ethereum virtual machine and how it should work, then that's definitely here inside this yellow paper as well. All right, so that's an overview of the Ethereum virtual machine and how it works. Now, in the next section, we're going to look at lots of other blockchains that have been influenced by the Ethereum virtual machine and, have implemented it as well, or their own variations, so that you can see, how impactful this has been, but also so that you can see how you can leverage your skills on multiple environments by just learning one programming language.